little break from our lectures. So today we are doing something, an exercise that's a little bit different from what you are used to doing during lecture. Okay. So today we are going to try out a planning question that involves chemical equilibrium. Okay. So I just want to give you a little bit context about this plane over here. Okay, now this 2015 paper 2 question 1 is a slightly different format for the exams. That's why the planning question comes out in paper 2. But for your new syllabus 9729, okay, your planning question is going to come out in paper 4. Okay, but I just want to give you a sort of a guideline as to how long do you think your examiners requires you to finish this planning question during A-levels. To finish this question, 2015 paper 2 question 1, you're only given 30 minutes, 30. Okay, right? So for your syllabus paper 4, you would be expecting to use about 30 minutes to complete the same question. Okay? So what we'll do is we'll look at the question together. We'll pick up some key points. I'm going to give you a little bit of time to work through some initial parts for this planning question. Then we'll look at the answers together. Okay? It is a very, very lengthy question. Okay? Very, very lengthy. So you will need to read and digest everything. Okay, because some parts of it is very important. Okay, and you didn't pick it up, you will find that you will get penalized along the way. Okay, so you have brought along the question, right? So take it out. I hope you didn't bring the whole book with you. You have, it's fine. If you don't, you just bring out the question and read through the question. Okay? There are some keywords that you should appreciate. Okay? What are some of the keywords here? Okay, first, see that the reaction is reversible. If the reaction is reversible, you will involve somewhat your equilibrium constant. So Kc must be involved at some point in time. Okay, the reaction rate is slow, so a catalyst is used. Okay, even with a catalyst, the reaction mixture will need to be left for 1 week to reach equilibrium. So when you are doing this experiment, it will take you 1 week. Right? So you need to factor that into your procedure. Okay? To determine the Kc value, it is necessary to determine, this is what you will need to do subsequently, to determine the amounts of acid that you use, alcohol that you use, ester that is formed, and water that is formed. Okay? Alright, so the different components of reactants and product. And then they go on to describe one way of doing this. Okay, so how would you carry out this experiment? You will add known amounts of a carboxylic acid, alcohol, and a dilute strong acid, which is a catalyst. Will then be mixed and stored in a sealed container. So what you need to do is, you need to consider what apparatus would you use to seal this container such that you can leave it there for 1 week. After sufficient time, which is 1 week, the whole mixture is titrated against a standard solution of sodium hydroxide. Now you see the word here, standard solution. Standard solution means you know what is the exact concentration of this sodium hydroxide. Okay? This will then allow the total amount of acid in the mixture to be found. Okay? Right, so when they say the total amount of acid in the mixture, you have realized that they didn't say whether is it the carboxylic acid or the dilute acid, because it is together in the same reaction mixture. So the total amount of acid in the mixture includes both the carboxylic acid as well as the dilute strong acid. Okay? Alright, so this total amount of acid is made out of the strong acid and the carboxylic acid present in the equilibrium mixture. So these are the keywords that you must pick up. Okay? Then they go on to say, over here, using this data, Kc we calculated, you take average of Kc values. Okay? So what are the key points once again? Okay? You will need to determine the change in amount of carboxylic acid present in the initial mixture and the equilibrium mixture. Okay? Such that you can reduce the amounts of each of the other components in the equilibrium mixture. Okay? You will need to repeat this several times using different initial ratios of reactants in each case. So you must do repeats. Okay? And then you will be required to write a plan for determining Kc value. Okay? Alright, so at the essence of this particular question, you are trying to determine Kc, okay, using titration. Right? They give you a data, and this data will be somewhat useful later on. Okay? Now part A, this part I will just go through with you all because we haven't learned organic chemistry yet. Okay, they say write a balanced equation to represent the reversible reaction between propanoic acid and methanol. Show the displayed formula of the ester. Okay? You have learned this before, so this is carboxylic acid react with alcohol to give you an ester, and your seniors, instead of telling me it's an ester, give me a name, ester. Okay? Not the same, and water. So, in this case, carboxylic acid is your propanoic acid, react with alcohol, methanol, to give you the ester and water. When they say displayed formula, all they mean is you need to show all bonds and show all atoms. That's why it is a displayed formula. But don't worry too much about this. Okay, we will learn this later on. Okay. I better don't mislead you all. So can I take out the, there's no dot here. This dot is from PowerPoint. Okay. I know if I don't remove it, some people will think that the dot must be there. Okay. Right, so this is the balanced reversible reaction. Okay. Okay. But I want to spend a little bit more time on part B, because part B is the part that is going to get the most number of marks. Huh? Can I move on to part B? Okay. No? Can I? Okay. Now part B asks that you may assume that you are provided with the following. 1 mole per dm cube sodium hydroxide. This is the standard solution. Okay? Approximately 3 mole per dm cube HCl, 10 grams of propanoic acid, 10 grams of methanol, and any equipment material usually found in a school laboratory. Okay. Then they guide you. In a planning question, usually examiners will guide you along the way by telling you what you will need to do. So if you have answered every point here, you would have answered the question. So what is required in your plan? Your plan, first bullet point says an outline of how the accurate concentration of HCl may be determined. So you need to determine what is the approximate 3 mole per dm cube of HCl, measure it accurately. So how will you do this? Okay. An outline of how the results will be used to obtain two different initial reaction mixtures. So in order for you to get 2 Kc value, you need to do 2 experiments. So how do you prepare 2 different experiments? Brief but specific details of the results would then be used to obtain the amounts in moles of 1, 2, 3. All the components in one of your initial reaction mixture. So this is at the start. Okay? What are the amounts of your acid, alcohol, okay? Ester plus water. At equilibrium, what is the amount of propanoic acid present? And all the other components present at equilibrium. Okay? For the purpose of this calculation, you may assume that 1.00 cm cube of HCl contains 1 cm cube of water, and that the density of water is 1 gram per cm cube. Which means that at the start of your reaction, there will be water because you have added in HCl. Okay, so you don't start with 0 moles of water at the start initially. Any relevant safety precaution you will consider important. So what are the safety precautions you need to take? So if I break down all of these parts over here, there will be some things that we need to take note of. Okay? Alright? In order for you to calculate Kc. Okay? An outline of how the accurate concentration of HCl may be determined. You need to do an acid-base hydration, right? Okay? So the very first bullet point requires you to describe an acid-base hydration. So what goes into the burette, what goes to the pipette? Okay? Second bullet point, an outline of how results will be obtained for 2 different initial reaction mixtures. How to prepare 2 different reactions. Okay, so that you can take average to find Kc. Third, it's a bit long, there are many things that you have to do. All the components in one of your reaction mixture. How to determine different known amounts of reactants and product. Okay? 2 propanoic acid present in this mixture at equilibrium. You will also need to do acid-base titration because you need to determine the total amount of acid present at equilibrium. From there, you will determine through calculation what is the amount of propanoic acid present in the mixture. Okay? Then for part 3, all the other components in this mixture at equilibrium, because you have only done an acid-base hydration, how can you find out what is the amount at equilibrium of your alcohol, water, as well as ester? There's no way for you to do that. So titration is not possible to answer part 3. What you will find very useful is an ICE table, which is what we've been doing for the past 2 weeks. Because if you have constructed an ICE table, you will be able to find out what is the equilibrium amounts of all the other reactants that's not acidic. Okay? Then the last bullet point, any relevant safety precaution you consider important. Okay, so what is so potentially dangerous about the experiment? Especially the reactants. And that's when you find that the question actually gave you the answers already because of the table that it gave you. So how do we ensure safety in handling all these reactants? If you can answer that, then this bullet point you have answered. So everything here is something that you can already do at this point in time. Okay? Alright, so now can I give you about 5 minutes? Okay? We work it out together. Can you spend 5 minutes to outline the procedure for you to determine the accurate concentration of HCl? Okay? Alright, this will be very short. Okay? 5 minutes. If you have any questions, please raise your hands and we will come and assist you. Okay?